Right, the next thing you need to know about ionic compounds is their properties, like you do with all of the different bonds. So let's go through them. I've got some pictures here. Now this is what sodium chloride would look like, if you could see it. So this is salt, common salt, and what we use, a word here that you need to be familiar with is lattice. It forms a lattice. That means it can keep building on. I can add another sodium here, another sodium here, another chlorine on this one. So it's a lattice. It's like a cube, this one, a framework that can just keep building. Whereas some other bonds, you can only have two together and that's it, it's finished. Whereas this one, you can just keep going, keep going, keep going. It forms this sort of three-dimensional cube shape. Here with one sodium to every calcium. You can see the sizes here. The sodium's smaller than the calcium, that's why they've done it like that. So they've got this sort of lattice effect. Now the properties of these ionic compounds are really two main ones that you need to know, and one is about the conducting electricity. Now, when you've got an ionic compound, if I put some salt like on the table and I put some electricity through it, it wouldn't go through it. It's a solid, it won't go through it. Electricity is a flow of charge, and the ions here, these ions here, have to be moving to enable the ionic compound to conduct electricity, and it will conduct electricity if the ions are free to move. Really, really important, free to move. It's a lovely answer for anything. Why do they conduct electricity? Because the ions are free to move. Really important. Let's work. That would be good, board. Thank you. All right, so here, this picture, complicated picture, there it is an undissolved sodium chloride. That's this, salt. And as soon as you dissolve it in water, look, you get them free to move. They've split apart and are moving around. So the electricity can flow from one to the other and it'll move with them. So they can conduct electricity because the ions are free to move, one, when it's liquid, so when you melt it, or two, when you dissolve it in water. So two things there, they conduct electricity when they are melted, or when they are dissolved in water. The other thing is, okay, so that's two things. One's the lattice there. This one is they conduct electricity when they are dissolved in water or molten because the ions are free to move. Because ions free to move. All right? Not in this one, not when it's solid, only when it's molten or dissolved in water. Now, they also have a high melting and boiling point. What's it got to do with cats? Well, it's got a lot to do with it. Anything I can get involved with a cat here. High melting and boiling point. Why? Because, okay, if you look at it, there is a lattice there. Each of these, the chlorine and the sodium, they have electrostatic attraction between them. That means they like each other. Electrostatic because these electrons, one's given the other one, they're not moving, these electrons, that's why it's static. So they've given them over, one electron's gone over there, they're not moving, static, and they're attracted to each other. Now, because of that electrostatic attraction, that force of attraction between them is really high. So the force of attraction between the ions is high. What's that got to do with cats? Well, here we go. Right, because here I've showed you a picture. These are like ionic compounds. These are the ions. They love each other. It would take a lot of energy to pull these apart. You'd need to pull them apart, and they don't want to come apart. So a lot of energy needed to overcome those forces of attraction. So a lot of energy needed. In other bonded things, other types of bonds, these would, well, they're sort of there. They don't particularly like each other. This wouldn't take much energy to split them apart. I'd just go, whoo, and they'd run off. Okay, but these two, oh no, I love each other. Right, so this is lots and lots of energy to pull them apart because they've got high forces of attraction between the ions. So they have a high melting and boiling point. This, on the other hand, is not an ionic compound. These two, take it or leave it, not really interested, not much energy to get them apart, just go whoo, and they go. These two, lots of energy. That's the properties of ionic compounds. Thank you.